Hi everyone! So today we'll go through the topic of nuclear physics focusing on radioactive decay. This is a topic from KSSM Physics Form 5. We believe that there were dinosaurs for centuries before. Did you know? By learning the radioactive decay, it helps archaeologists to identify the age of the dinosaur fossils. So what radioactive decay is? Before we get started, let's look at the learning outcome for today. The learning outcome 6.1.1 requests us that at the end of the lesson, you will be able to explain with examples decay equations, which are three of them. The first one, the equation of alpha decay. The second one, the equation of beta decay. And the third one is the equation of gamma decay. So make sure that at the end of the lesson, you understand, you can explain, and you can give the examples of the three equations. All right? There's another name for radioactive decay. We also call it as a radioactivity. Do you know what radioactivity is? Okay, come, let's read it together. Radioactivity is a spontaneous decay of an unstable nucleus by emitting alpha, beta, and gamma decay. So, when we talk about spontaneous decay, is it planned? Nope, it's unplanned. And can we predict it? Also, nope, it's unpredicted. We just leave it there and it happens just like that. So, since it is also random, it is not affected by temperature or pressure. So, this radioactivity is a spontaneous decay of what? Of an unstable nucleus. Okay, so when we talk about the unstable nucleus, it usually happens to heavy atom with heavy nucleus. And when this radioactivity happens, this nucleus will emit alpha, beta, and gamma decay. So, the unstable nucleus, we call it as parent nucleus. It will decay and give results of daughter nucleus. So here we got a mother-daughter relationship. Quite interesting, huh? And this is also very important. Can you recall what nucleus is? You still remember when we talk about nucleus, is it the one surrounding an atom or is it the one in the middle? Yep, nucleus is the one in the center of an atom. It consists of proton and neutron. Neutron pula. Neutron. Okay, so how about the electrons? Does the nucleus carry electron as well? The electron is not in the nucleus. It is surrounding. The electrons are surrounding the nucleus. There is an atomic notation general for the atom. So atom is represented by X, and we have the mass number of the element at the top corner, at the top left corner of the atom, and at the bottom left of the atom is the atomic number. So since we are talking about alpha decay, beta decay, and gamma decay, so we by right should know what is the alpha particle, beta particle, and gamma ray. Alpha particle is actually a helium atom. Beta particle is actually an electron particle. And gamma ray is a type of electromagnetic waves. This is an example of the alpha decay. Alpha decay happens when an unstable nucleus decays by emitting a helium atom, which is called alpha particle. That's why it's called alpha decay. So the parent nucleus at the left one, it will become unstable and it will decay, producing a daughter nucleus emitting an alpha particle. So as you can see, the equation The general equation there is an atom with A mass number and Z atomic number. It will decay and the A will reduce to A minus 4. How about Z? Also will be reduced to Z minus 2. Why 4 and 2? Because alpha particle, it has 4 mass number and 2 atomic number. Does it make sense? Yes. So as you can see, the left side, the left-hand side, our left-hand side and our right-hand side must be balanced. If at the left-hand side we have A, at the right-hand side also we need to have sum of A. So as you can see, A minus 4 plus 4, that will give you A again. And also Z. Z at the left side and then at the right side, Z minus 2 plus 2. Also will give you Z. See, you need to be balanced. Now let's take a look at an example of alpha decay. So right here we have uranium-238. It will become unstable and it will decay and become thorium-234, emitting alpha particles. So as you can see at the equation down there, at first uranium has only has 234 mass number. Suddenly the mass number drops to 234, which is 238 minus 4. Obeying the general equation that we got just now. Okay, this is gotten from through experiment. Okay, so this one already proven. So the atomic number also from 90 becoming 88 means it drops by 2. So this is example of alpha decay. Next one. After alpha decay, one done, another 2 more. Beta decay. So we have an unstable nucleus, parent nucleus, unstable and then it will decay becoming a daughter nucleus and emit an electron particle, which is the beta particle. So at the bottom there, we have a general equation for this decay. So at first we have an atom, and as you can see, the A will remain the same. Why so? Because electron has no mass number. It has 0 mass number. Okay, and since electron has -1 atomic number, that's why the daughter nucleus will have one number more than the parent nucleus. You see that? Okay, how about we take a look at an example. Here is an example of beta decay. So at first, we have carbon atom with mass number 14 and atomic number 6. As you can see, the mass number remains the same after the decay. Why? As what I said just now, because beta particle has no mass number. And since the atomic number is -1, this makes the parent nucleus rise by 1 number. From 6 become 7. So it will produce nitrogen atom with a atomic number 7. 2 done. Just now we have done the alpha decay and the beta decay. Here comes the third one and the final one. So when we talk about gamma decay, this is very interesting, because why? The parent nucleus and the daughter nucleus, they have the exact same number of mass number and atomic number. Interesting, right? But it will emit gamma ray with no mass number, with no atomic number. But what is different here is that maybe the energy of the parent nucleus and the daughter nucleus might differ. And also, another interesting thing about this gamma decay, this also can be happening to alpha decay and beta decay. It means that while alpha decay is happening, gamma decay also can happen at the same time. Gamma decay can also be emitted when a nucleus undergoes alpha or beta decays. Okay, this one need to remember. For example, during uranium-234 decay, it emits alpha particles, right? And it also emits gamma ray. Okay, also another example of gamma decay. At first, we have a parent nucleus of thorium-234, and then it will decay, become thorium-234 again. It doesn't change, but it will emit gamma rays with 0 mass number and 0 atomic number. We are already towards the end of our lesson today, so how about you test yourself first before you leave? Okay, question number 1. The nucleus of an atom consists of A. Proton only, B. Neutron only, C. Electron only, D. Proton and neutron only. Which one? Do you still remember? Proton. Do we have only proton in a nucleus? No, right? Do we have only neutron? And how about electron? Definitely doesn't make sense at all because electron is surrounding the nucleus. So the only answer here is D, proton and neutron only. Moving on to question number 2. Da-da-da. Okay, this question is taken from Focus Physics Pelangi book SPM Form 4 and 5. Alright, so this is following the new syllabus. So the question here is, Figure 1 shows an incomplete decay equation. So we have a parent nucleus here with mass number 192 and the atomic number of 77. What happens after the decay? Okay, so remember what I said just now? The total number at the left hand side must be the same as the total number at the right hand side. So meaning the total number of mass number at the left hand side must be balanced with the mass number of the right hand side. So since we have 192 at the left hand side, so meaning we also need to have 192 at the right hand side. So looking at the answer, looking at the choices, C and D definitely incorrect. So we are only left with A and B. So since we have the atomic number of 77 at the left hand side, we need to pick something at the right hand side to make the sum 77. Okay, the only one is A because it has a value of 192 and a Z value of 78. Did you get the same answer? If you do, good job. Congratulations. Okay, now let's move on to question number 3. Question number 3. An atom Y with A value 230 and Z value 91 has decayed and produced a nucleus A, an alpha particle and a beta particle. What is A? So here we need a paper. Make sure that the 230 at the left hand side is balanced with the total A at the right hand side. So here we have alpha particle with A 4 and a beta particle with A 0. Hence, we already have 4 at the right hand side. To make it balanced with the left hand side, we need to minus from 230. So we're left with 226. Oh, since all the choices is 226, okay, we got no choice except checking the atomic number. Since the left hand side gives us atomic number of 91, meaning the right hand side also must give us the sum of 91 as well. So since alpha particle has 2 Z value and beta particle has -1 Z value, that one will already give us a value of 1. So we're only left with 90, right? Because 91 take away 1 give us 90, which is C. Did you get the same answer? If you do, congratulations. Now, moving on to question number 4. Question number 4. The following equation represents an alpha particle. X decay to Y plus alpha particle. Which of the following is correct about element Y? Proton number, no change. Huh? Really? Nuclear number increases by 1. Okay, now when we talk about alpha particle, does alpha particle has any atomic number and mass number? Yes, it does. It has mass number of 4 and atomic number of 2. So it must have the change in the proton number and nucleon number of the daughter nucleus. So question answer A and answer B definitely incorrect. So we are left with C and D. Since alpha particle already has a mass number of 4, meaning the proton number must be decreased by 4. And since alpha particle has an atomic number of 2, so hence the parent nucleus must reduce the atomic number by 2. Thus, the only answer for element Y is D. Okay, did you get the same answer? If you do, then congratulations. You did well today. Before we end our lesson for today, let's just do a quick recap. So you have learned the 3 decay, which are the alpha decay, the beta decay, and the gamma decay. Please remember that alpha decay is actually helium atom with A value of 4 and Z value of 2. Beta decay is an electron with A value of 0 and Z value of -1. And gamma decay is just an electromagnetic waves with no mass number and no atomic number. So please remember this, and I hope that you can apply it in your exercise and also SPM. Good luck! So that's all for today. Thank you for watching. See you in another lesson. Bye!